background you can see. Can you identify which is that place? Background कहाँ है? ऋषिकेश इतना दूर गया? हाँ? हल्द्वानी, काठगोदाम कितना लोग देखे? काठगोदाम, हाँ? गोदा बैरेज, हाँ? गोदा बैरेज देखा है? Just on the, I think you know that Gola barrage also. That is a barrage is new one, which has been which you are going to visit. That Gola barrage is a new one. That is not an old one. Old one was just backside of that one. I think around maybe 80s, probably 80 or 85, something like that. Earlier barrage which was there, okay, that has been washed away because of heavy floods. बहुत बारिश आ गया, वो पूरा निकल गया. पहले छोटा बैरेज था. It was a very small barrage at that time. Okay, that Gola barrage that used to supply water for irrigation. Okay, I think still people are calling Gola Par and Gola War. I think those who are from Haldwani, they know well rather than me. Gola Par means on the other side of the barrage, and Gola War means this side towards the city. Okay, so there are two canals. They are just water is flowing like this in that Gola river. They put the obstruction. Obstruction is just to store the water or to raise the level of the water such that water will flow on both the sides. So left side also, right side also. Okay, when you are calling it as left bank canal and right bank canal means you must stand along the flow of the river. Okay, you just stand along the flow of the river. Your left side is left bank and right side is right bank. Okay, that also you should aware. In general, earlier the water was used for irrigation purpose, but since that city has developed and most of the irrigation water which were using earlier, now they are using it for industries as well as domestic purpose. Domestic means आपका water supply घर के लिए Haldwani and other extended areas, they are using the water from Gola river. Okay, so note that there are different methodologies which are available to measure the water which is flowing in a river like this. Okay, ये तो because I think still you know Q is given by area into velocity. Area is cross sectional area. Okay, cross sectional area, and what is the velocity of the water? Okay, water velocity. If we just multiply that one, you will be getting what is known as how many cubic meters of water is flowing per second. That you can get it. Anyway, thoda science aa gaya. I will not go to the details of that one. So that you need to measure it, and there are different methods are available. Like example, area velocity method. Just now I said you have to find out the cross sectional area and the velocity. We can get the value of Q. Similarly, there is a dilution method is also available. Okay, dilution method is known as chemical method. आप कोई velocity measure करेंगे, कुछ भी नहीं measure करेंगे. Just by the concentration of the, we used to call it as some chemical or tracer. Okay, that we are using in case of dilution method. हम इधर एक concentration छोड़ेंगे. Up to some distance, we are just measuring the concentration of that, how much concentration the tracer presents. That will provide you what is the amount of water which is flowing. Okay, and of course, it may be even there are some flow measuring structures like barrage. I was telling Gola barrage. I was giving an example. I will show you just by measuring the height. You will be in a position to say so much amount of water is flowing in the river. That you can see. अभी कोई डेली कोई नहीं जाएगा उधर गोला रिवर में. हाँ, आज बारिश आ गया, इतना पानी जा रहा है. So many 5 cubics of water is flowing in the Gola river. Okay, that they used to say. But no one will go and measure daily. It is impossible. इतना बारिश आते रहते हैं. I think you might have observed yesterday, day before yesterday, or in another few days also, heavy rainfall used to occur, and how much water is flowing in that Gola river. Okay, no engineer will go, no attendant will also, you will not be going. he is just observing the values, or he is just observing the level of water, okay, and he will say, yes, this is the amount of water which is flowing in that river. Okay. Anyway, that is one of the method, or even nowadays ultrasonic methods are also used, okay, or even electromagnetic methods are also used, that you can use it for your purpose. Even nowadays, even satellite imageries you can use it. आप देखिए गंगा रिवर somewhere near Varanasi, or maybe at those places, or maybe even Gada also, Gadmukteshwar. It's so vast. Oh, width of the river, can you expect how much at let us say Kashi, Benares? What is the width of the Ganga river? Any estimates? Hmm? Huh? Any other guess? When it is flooding, अभी तो सारे घाट्स फुल हो गए उधर, आप घाट भी नहीं जा सकते, आप बोट भी नहीं जा रहे अभी, वो गंगा कौन सा गंगा दर्शन ना, गंगा आरती देखने के लिए बोट में जाके पानी में रहते थे, अभी कोई बोट अलाउड नहीं है. All the ghats have been full, and some of the low lying areas, बनारस भी अंदर पानी घुस गया. Okay, you know what is that width of the river at measuring station, because there is a Central Water Commission's gauging site is there. Central Water Commission is the agency which controls or which measures the water of Ganga river at different places. So Varanasi is one of the gauging station is there. Okay, at that place, during when the water flows fully, it will be around 3 to 4 kilometers width of the river, not the length. Okay, width of the river may go up to 4 kilometers or beyond that one also. Width of the river I am talking about, and depth is also, depth is also increasing gradually. Okay, even at Gadmukteshwar also it may go up to more than a kilometer. Gad janta hai na idhar, on the way to Delhi. So there also it will be almost 1 kilometer width will be there. That's why particularly it's a huge length of the bridge is required at that place. Okay, so note that, okay, at those places none of your small equipment doesn't work. Then you need to go in for satellite imageries, because many satellites are there in the space. Okay, maybe Indian satellite, or maybe US satellite, or maybe UK, European Union. So many satellites are revolving. They used to take that continuous movement, okay, continuous imageries. So scientists or engineers, they will analyze and they will say, yes, today this is the amount of water which is flowing in that river, because 4 kilometer कोई instrument नहीं चलेगा. Okay, you can't use it. So based on the imageries, satellite imageries, yes, you will be in a position to say this is the amount of water which is flowing in a river or stream, that you can say. So I am just listed, okay, some of these different methods. In broadly we can classify two types. One is direct measurements, okay, other one is indirect measurements. Direct measurements means we are directly measuring the flow. Suppose this is the canal, I am just taking the distance from here to here, let us say 1 meter. What is the depth I am measuring? So if I say length into breadth, I am going to get the area, and I am using another small instrument known as flow measurement, that is velocity. I need to find out the velocity. What is velocity? Distance divided by time. यहाँ से पानी यहाँ से उधर जाने के लिए कितना टाइम चाहिए. Okay, so that can be measured by various ways. Velocity. Can anyone say what is a simple method of measuring the velocity? Simple method. Huh? Roughly, crude method, I should say. डिस्टेंस कैसे मेजर करेंगे? हाँ, ओडोमीटर तो आपका बाइक में रहेगा, स्पीडोमीटर है ना. So by using a wheel in the river, we can how many revolutions? Yeah, anyway, it is based on the same principle only, but we are not calling it as a current meter. We are calling it as a current meter. Current meter is an instrument used to measure the velocity in a stream. Okay, current meter means current measure नहीं करेगा वो, current meter. Okay, It's an instrument. Current meter is an instrument used to measure the flow in a stream. Okay. Abhi, just now I was telling you, okay, velocity is distance divided by time. Okay. और भी कोई तरीका है? Simple way. Okay. I think आप लोग I don't know, nowadays you people are playing with the water or not, I am not aware. वो एक पेपर बोट करते थे, okay? पेपर बोट इधर छोड़ते थे, it used to flow along the stream or river. Okay, so can you measure with that one? Yes, आप इधर वो बोट एक पेपर का बोट बना दीजिए, इधर पानी जा रहा है इधर, okay? इधर बोट चल दिया, टाइम जस्ट टाइम देख लीजिए आपका वॉच में, घड़ी पे, देन लेट अस से दिस इज सम 10 मीटर्स डिस्टेंस है, सो उधर जाने के लिए कितना टाइम लगेगा, आपको डिस्टेंस तो पता है 10 मीटर्स अप्रॉक्सीमेटली, ओके, एंड यहाँ से उधर जाने के लिए टाइम देख लीजिए, वो बोट उधर पानी के साथ ही जाएगा ना, ओके, सो यू कैन मेजर द डिस्टेंस, डिस्टेंस बाय टाइम इज वेलोसिटी, सिंपल मेथड, ओके, सिंपल दैट आई थिंक पेपर बोट का अभी ड्रिंक्स भी आ गए लगता है ना, that some brand name has been in the name of that boat, okay. Anyway, that is the simplest method. We used to you can use floats also, simple float. Float means something which is floating in the stream or river, okay, it should float, okay, and it will be moving, so you can measure how much time it will take to travel to that distance. So velocity तो distance पता है, time कितना हो गया वो भी पता है, so you can say this is the velocity which that water is flowing, okay, that you can find out. That is the simplest method without any investment. आपको एक पैसा भी खर्चा नहीं होगा, आप पेपर डाल दीजिए, not necessarily paper, it may be some plastic item, okay, ये plastic item डाल दीजिए, okay, नहीं हो तो wooden item डाल दीजिए, some wooden log, okay, so you can put it here, that will move and you can find out the distance divided by time, you are going to get the velocity, and the area तो पता है, you can measure it, ये 2 फुट है 4 फुट है, so you can find out the discharge or how much amount of water is flowing in a crude way or rough way, okay, that's also possible, okay. So that's why I am saying that is known as first method, area velocity method is the same. Area means cross sectional area and velocity, so if you multiply area by velocity, you are going to get the Q, okay, simplest method, and of course there are sophistications also, that's also possible. I will just show it to you if time permits. So second method is dilution technique, okay, dilution technique. So here also I think those who are from chemistry, okay, they know this dilution technique. आप पानी में, how to explain that one, you know, potassium permanganate KMnO4, उसका कलर क्या रहता है, pink color. So water is flowing, we just put that KMnO4 here, वो पानी में डाल दिया तो that will become spreading, or that color will change from here to there. So you can just observe the concentration of that KMnO4 at this point, and you observe the concentration at that point, okay. Here it is too much concentrated, that concentration will reduce over there, okay. So that concentration from here to there, change in concentration is indirectly proportional to the amount of water which is flowing. So that concept or that principle, वो तो I think आप लोग मोस्टली थर्ड और फोर्थ मे बी फिफ्थ स्टैंडर्ड में साइंस में पढ़ता है, ओके, लॉ ऑफ कौन सा, कंजर्वेशन ऑफ मास और समथिंग लाइक दैट, ओके, हाँ, that law has been applied and you can find out change in concentration from this place to that place, okay, you can measure the flow. So that is the method is known as dilution technique. That is, you are not measuring any physical width, कुछ भी नहीं करेंगे, you are measuring only the how much solution, that is what is the concentration here, what is the concentration at that place, okay. The change in concentration is directly proportional to the flow which is flowing in that stream or river. Then comes, of course, electromagnetic method. Okay, so you can use mechanical methods or even that magnetic property, okay, of that will change because of the flow of the water, and that depends upon the velocity. If the velocity is too much, magnetic characteristics will be changing. Okay, so that concept has been used. It is little bit technical. Then comes ultrasonic method. Okay, so many, I think nowadays ultrasonic method or sensors are quite common. Okay, so different types of sensors also can use it. You can use it for your flow measurement purpose. Okay, ultrasonic method, it is latest. So these are all I am calling it as direct methods. Why? All these instruments, okay, we are just touching the water. Okay, all these instruments, whether it is an area velocity method or ultrasonic method, we are putting some instrument or equipment and we are measuring. That's why that method is known as, okay, ultrasonic, sorry, direct methods. Similarly, there are some indirect methods that you can see. Okay, like you can use hydraulic structures. Hydraulic structures, not this, not simple structures. Okay, hydraulic structures means related with water. So can you name some of the hydraulic structures? Huh? Yeah, as you said, it may be a dam. Okay, it may be a barrage like a Gola barrage. Okay, गोला बैच कितना लोग देखा है? ओके, आपने कुछ ऑब्जर्व किया ऑन द दोनों बैंक में, ऑन बोथ द साइड्स वाटर इज फ्लोइंग, उसमें कुछ मार्किंग किया है दोनों साइड में, लेफ्ट साइड और राइट साइड कोई भी हो. Okay, there are some markings. Okay, so those markings are used for measuring the amount of water which you are going to release it or which is flowing. That can be measured in that place. Okay, so that those are known as hydraulic structures. And as you said, it may be a notch, it may be a weir, or it may be a gate. I think इधर गेट देखा होंगे आप लोग, कौन सा हॉस्टल यार, फर्स्ट दैट नहीं, फर्स्ट हॉस्टल इज नहीं, गांधी नहीं मैडम, आगे ठाकुर टैगोर भवन ना, टैगोर भवन के बाद यू विल फाइंड सम स्ट्रक्चर्स, दे आर नोन एज हाइड्रोलिक स्ट्रक्चर्स. गेट का वो पानी का गेट डाल के रोका है इधर. Okay, that stream is there, they put some vertical gate and those gates are also can be used to measure the flow. That is also possible. Okay, सिर्फ इधर ही नहीं है, वो बेनी चले जाइए और आगे. Okay, उधर भी गेट लगाया है. Okay, so those areas you can find out how much water is flowing in that stream. Okay, there is a general question once again to you. Okay, I think my students, they know, others you can answer, others please. There are, you know, there are 3 rivers or streams are flowing in Pantnagar campus. 3. Can you name them? George, Chakperi 1, huh? Beni River, Baror. Yeah, so good. So you know there are 3 streams which originates within the campus itself. Because most of us, even after staying for 10 years, 15 years, they are not aware. There are 3 rivers. Okay, they are very small here because it is the area where they will get water. Okay, that will flow through those streams or rivers, because many streams will join and it will become a river. Okay, so as someone said, Chakperi river कहाँ है? बड़ी मार्केट, वो IGH के बगल में. Okay, IGH के बगल में, वो उधर से वो ऊपर से आता है. Okay, so the Chakperi river, then here on the way to Nagla you will find Beni and Barur also. Okay, so 3 rivers are joining and they will join together and they will once again join to Gola river. गोला जा रहा है ना इधर, गोला किधर है? लाल कुआं के पास. Okay, so water, these 3 rivers, water will once again join to that Gola bigger river or bigger stream. Okay, so in that way, okay, So you can use these hydraulic structures like weirs, flumes and gated structures. ये फ्लूम्स देखिए अक्टूबर में आपका किसान मेला होता है ना, you will find different types of flumes, partial flume, hydraulic flumes will be there. So those are also structures which you can use it indirectly to measure the flow. Water will be allowed to flow through those flumes, and you can measure you can say so much of amount of water is flowing. That's possible. And किसान मेला में एक स्टॉल रहेगा टेक्नोलॉजी वाला में, irrigation department में, you can just observe those flumes also. Then of course satellite method I already discussed. Satellites can be used even to measure the flow. Then comes your slope area method. As the name itself indicates, we are not measuring the velocity here. You just see the difference. Area velocity means cross sectional area velocity. But either area तो रहेगा, but what is the slope from here to there? ये gradient horizontal है और कितना gradient है? Okay, so that slope itself, it indicates how much amount of water is flowing in that one. There is also another method where we can use it, the methodology, how to measure the water. And I think, okay, you can just see these gauges, wherever you are going to measure it, it should have some standard requirement. And you can just read it. I will not go to the details of that one. I am just saying, okay, wherever you are wants to measure it, okay, that should be easily accessible. Easily accessible means मैं easily उधर जा सकता हूँ. Okay, don't select a gauging station somewhere in forest area of a Nainital, और उधर नहीं जा सकते ऐसा एरिया मत सेलेक्ट करिए. आप कैसे मेजर करेंगे? उधर जाने के लिए ही दिक्कत है, 10 किलोमीटर पैदल से चल के जाना एंड उधर मेजर करना. डोंट सेलेक्ट the place which is inaccessible. It should be easily reachable. So that sort of site you need to select it. Okay, so that is one of the condition which you should think of, and there should not be any turbulence. Okay, turbulence should not be there. Then of course don't select a site where exactly that dam has been built. Just upstream of the dam or downstream of the dam or hydraulic structure, don't select that site also. So these are some of the general requirements which you need to look it into, and there should be a permanent site. I think बाकी लोगों को नहीं समझेगा इतना easily. Okay, I am just skipping these things. That the bank should be permanent. It should not wash away. I think some 2-3 years back, you might have observed the bridge which is connecting between near Haldwani, one side of that bridge has been washed out. Okay, so that place don't select it. It should be permanent. Okay, and it should be steady. That sort of. So I said simple methodology, velocity, area method. So we should know the cross sectional area and velocity. So these two things only require it. Someone was saying how to measure it. So this is a simple instrument which is known as current meter. Current meter means current measurement के लिए नहीं है, ये water flow measurement का water का velocity measure करेगा. Okay, so I will just show you the actual instrument which we have it in our laboratory also. So it is like a, okay, what I should say, it consists of series of conical cups. Okay, and because water is flowing, so the cups will rotate. Okay, and that will be connected to an electrical connection, and or maybe some sensors, such that you can say, yeah, this is the velocity which it is flowing. Okay, and note that at the bottom, because आपका when the current meter is inserted in the water, it should be straight. ऐसा भी नहीं होना, टेढ़ा भी नहीं होना चाहिए. Okay, or it should be not be like this. It should be straight. That's why this sounding weight has been provided over there. Okay, and sounding weight also, even if you provide it, you must provide in such a way that, okay, that should not disturb the water. Okay, you just see that is in the shape of a fish. Okay, I think you know, aircrafts, they are like fish only. That shape of that aerodynamic shape is to call it. Why that shape is like a fish? You see, whenever that aircraft moves, or you can say, take the case of fish itself. When fish moves, it should offer least resistance from the water. Like that, air is also a sort of water only. It is also a form of water. I said liquid, solid, and vapor stage. So, in that air, when the aircraft moves, it is cutting that air. Okay, and that should offer least resistance. That's why that aircraft has been made like a fish, because fish is a natural animal, or whatever you can say. That naturality, scientists or engineers have observed for a longer period. Yes, fishes are moving always against the flow. पानी ऐसा जा रहा तो fish opposite में जाएगा. Okay, you can just observe over there. They are not moving along the river. No. हल्द्वानी से लालकुआ आ रहा तो पानी रिवर, गोला रिवर में ऊपर से नहीं आएगा फिश, नीचे से ऊपर जाएगा. दे आर ऑलवेज मूविंग, फिशेस आर ऑलवेज मूविंग अगेंस्ट द flow of water, against the flow of the water. So, here also that fish has been studied by many scientists and engineers, particularly aerodynamic engineers, and they built that aircraft such that minimum resistance from the air will be there, so that it will be more efficient, or that travel of that aircraft is more efficient. I think some time back, a very well known what is Olympian, you know, Michael Phelps, no? Okay, that guy has invested a lot to study, because he has to move, swim. Okay, he has to swim faster than others. Okay, and he studied, or he appointed an advisor or doctor, whoever may be, scientist, such that when he wants to swim, his swimsuit must offer least resistance to the water, because he has to swim and he has to move fast, such that he can get a gold medal or whatever maybe. He got it. Okay, almost continuously he got it for so many years, because he has invested a lot to just to study the dynamics of that fish. Okay, and his swimsuit has been designed based on that natural principle itself. It is just a real story or real incidents. Okay, that means that whatever I want to say is that instrument should offer least resistance to the flow. That sort of instruments you need to use it. Okay, so that's why it should be vertical. To keep it vertical, we are finding a heavy weight. Okay, it may be around 10 kg, 20 kg, something like that, and that sounding weight should not offer resistance to the flow. Okay, and they should be made up of this shape, and that is the reason why this shape you can observe over here. Okay, this is known as conical cup current meter or vertical axis current meter. So, the axis is here, and about which the propeller rotates. It may be possible horizontal also. If you put a question, yes, that is also possible. Even in our vehicles, propeller, we used to call it, the propeller rotates like this horizontally, but here it is vertical. You can just observe that also. I will just show it to you. ये छोड़ दीजिए, मैथमेटिक्स वगैरह नहीं चाहिए. Can just see. Can you spot the difference between earlier one and this one? Here the propeller rotates about the vertical axis. Okay, it may be rotating about the horizontal axis. Both are possible. Here it rotates about the vertical axis. Okay, you just see the actual current meter. Earlier one was schematic type, which we have it in our laboratory also. Because we don't have time, that's why I did not show it to you. But you can just see, this is a fish weight, sounding weight we used to call it. It's a heavy weight. कुछ नहीं है वो, it is made up of a fish sort of thing, such that it is offer a least resistance to the flow, because ये तो पानी में डूब जाएगा ना. So it should offer least resistance. That's why this is made up of a fish shape. And side में wings भी रहेगा, even in aircraft also. Okay, flights also. There will be wings that provides a stability. नहीं होगे तो ऐसा हो जाएगा, otherwise like this. So it should be stable. That can be controlled in the wings, whether it is an aircraft or even in fish also you can just observe it. वो टर्न होने के लिए वो साइड वाला ये रहता है, फ्लैप्स रहते हैं ना, that will change that direction. Okay, anyway, that you can observe whenever you happens to fly, or maybe you can observe the fishes also. You will come to know this principles or technology. That thing is applied, and you can just see there is a counter. Okay, there is a digital counter. It may be mechanical also, it may be electrical also. Electrical means bulb glow हो जाएगा, ये तो digital है, और mechanical also possible, that rotation वाला कितना rounds हो गया. So that indicates what is the velocity of the water which is flowing. That's possible. Okay, so this is vertical axis current meter. Okay, yeah, I was telling you about horizontal axis. Okay, you just see like this. It's like a propeller. This is like this. Okay, in the horizontal axis it rotates. This is that horizontal axis. You can just see the difference between horizontal axis as well as vertical axis. Okay, so this is an equipment for small channels only, not bigger ones. Yes, we can use this equipment for measurement purpose. Yeah, different streams. We can use different types of measurements. I said that for small streams or small rivers, you can use these current meters. But if it is too big, okay, you can use boat methods also, or satellite imageries also. That's possible. Okay. Just now I was discussing some time back, if the river is too big, 4 kilometer, 5 kilometer, if that is the case, okay, how to find out the velocity? This indicates. I will not, once again, I will not go into details, because velocity is not same at all the places. It may differ from one place to another place within that cross section itself. Okay, आप क्या करेंगे, इसका छोटा-छोटा डिवाइड करके हर एक का वेलोसिटी अलग-अलग करके अलग-अलग Q find out करके then you will be adding. That's what it shows it, and you can just see how that velocity also varies. Okay, ऊपर ज़्यादा रहेगा, नीचे कम रहेगा. Not only in vertical, horizontal भी. Okay, side पे velocity कम रहेगा, but at the center it is maximum. That's why while swimming, be careful whether it is a Ganga river at Rishikesh or Gola river at don't go to the center, velocity is too much. Even you may be aware of swimming, fine, but side पे तो ठीक है, velocity कम रहेगा because of the resistance. Even at the bottom कम रहेगा, but at the center velocity is too much. Heavy velocity will be there. That's why that drowning cases will be there. Okay, if it is deep, as well as if we go to the center, be careful, particularly those who are going for swimming purpose. You just see how that velocity varies. Okay, on the sides, stream bank, at the center it is maximum, not at the sides. Sides it may be 0 also, but at the center it is maximum. Similarly, along the depth, you can just see that it is a typical cross section has been given. At the center, somewhere down, not at the surface. Surface में तो कम रहेगा velocity, but इधर देखिए, उसका नीचे ज़्यादा velocity रहेगा, and those are the dangerous points. Okay, one should not go at that point, even if you are expert in swimming. Okay, it is very difficult to control your swimming at that place. मैथमेटिक्स छोड़ दीजिए. हाँ, ये देखिए, बताइए आप. ये देखिए, ऊपर कम रहेगा because of air resistance. Air resistance. है ना, और नीचे भी कम रहेगा बिकॉज ऑफ वो फ्लोर ग्राउंड रेजिस्टेंस, और साइड पे भी कम रहेगा बिकॉज ऑफ बैंक्स. ओके, एंड वंस अगेन ये तो रेगुलर शेप है, रिवर थोड़ी ऐसा रेगुलर शेप रहता है, वो तो इरेगुलर शेप रहता है. दैट ऑल्सो वेरीज. इधर तो मैं सिंप्लीफिकेशन के लिए ट्रेपेजॉइडल ले लिया. नॉट नेसेसरली, ट्रेपेजॉइडल विल नेवर एग्जिस्ट, ओनली इन केस ऑफ कैनाल्स, लाइक गंगा कैनाल है, अपर गंगा कैनाल और लोअर गंगा कैनाल. ओके, कैनाल में तो ठीक है रेगुलर रहेगा. और इवन यूर कौन सा जगह है, रामनगर वाला. ओके, रामनगर देखिए आप, ट्रेपेजॉइडल शेप है. ओके, उधर सेंटर में हो सकता है, बट नॉट एट ऑल द प्लेसेस. नेचुरल रिवर में ये गोला रिवर कहाँ है, ऐसा तो है ही नहीं, कंस्ट्रक्शन ही नहीं है. दिस इज applicable only for canals. Canal is nothing but a regular shape. It may be rectangular, trapezoidal, or like that. But if it is irregular, it's very difficult to predict where exactly that maximum flow velocity will be there. So at that place you must be careful. Otherwise, I think many cases are happening because of this. वो सोचेगा साइड पे तो वेलोसिटी कुछ है ही नहीं, चलो जाएंगे, ऐसा अंदर चला जाएगा, अंदर ही चले जाएगा वो. Anyway, I'm just skipping those things. So there are sounding. Supposed to find out the depth, you just keep the instrument at the top, that it will find out how much deep that water is level. आपको पूरा ये लगाने नीचे तक लगाने की जरूरत नहीं है. You just keep it on the surface, that echo sounders, and it will measure how much deep that water depth is. Okay, that is also required for finding out the area. They are known as echo depth sounder. Anyway, ये डिटेल्स छोड़ दीजिए, इसका तो जरूरत नहीं है. हाँ, ये देखा होगा आप लोगों ने, सेम गोला रिवर ओनली दिस सॉर्ट ऑफ मेजरमेंट्स आर देयर. ओके, स्टॉफ गेज, उसमें हाइट देख के दे विल से सो मेनी क्यूमेक्स ऑफ वाटर इज फ्लोइंग. This gauge is also known as, it's also a different way of measuring the how much depth of water is flowing. मैं तो velocity बता दिया, okay, what is the velocity, but how much depth of water is flowing, you can use this gauge, that is known as float gauge. ये भी पुराना हो गया अभी आजकल. This is stage height. The river is connected to an gauge and you can measure it. ये देखिए, दिस इज जस्ट एन दिस सॉर्ट ऑफ थिंग्स. ऊपर वाला है ना, ऐसा वाला आप गोला बैरेज में भी देख सकते हैं. मीन्स पानी कहाँ तक का है वो देख के यू कैन से दिस इज द अमाउंट ऑफ वाटर विच इज फ्लोइंग इन द स्ट्रीम, यू कैन सी. ओके, ऑल दिस थिंग्स आर जस्ट टू मेजर द फ्लो ओनली, नथिंग एल्स. कितना पानी जा रहा है आपका स्ट्रीम और रिवर में, यू कैन मेजर इट. दिस इज टेकन फ्रॉम वेयर इन जर्मनी. इंडिया में भी वही सेम कॉन्सेप्ट ओनली. आई थिंक ये फ्रांस वाला यूरोपियन यूनियन गए थे, वो लोग बता सकते हैं वो कहाँ है. एंड दिस इज, यस, यू कैन गो फॉर सम अल्ट्रासोनिक मेजरमेंट्स आल्सो. ओके, यू डोंट नीड टू पुट योर स्टॉप फॉर कुछ भी नहीं, जस्ट कीप द इंस्ट्रूमेंट एट द सरफेस, यू कैन मेजर द हाउ मच डीप दैट इज पॉसिबल. ओके, how to take the reading and other things, that is there. Nowadays it is all computerized. I am just skipping. I think आपका क्वेश्चन ही somewhere here it is there. छोड़िए, उसकी जरूरत नहीं. So even in concentration method also there are different methodologies. I will not quote the details. There is a sudden injection method, constant injection method, etc. So after two sections, you can use that for measuring the water. So this is electronic method, ultrasonic method I just discussed. So this is the flumes and vias which we can use it for measurement of your flow. These are different methods I am saying. Which method I need to use it, you need to decide based on your technical capacity or human resources. the instruments available, or the width of the river, or how much amount of water is flowing. That all decides these methodologies. Yeah, you can just see simpler methods only. So these things you can. This is not a flume. That is a weir. Okay, here also there is a weir, and you can use these methodologies. I think, yeah, someone was saying simple V notch, so you can use it for your purpose like this. Partial flume, you can use it. Okay, you can just needs to know the depth or height above which water flows, and that will provide you the Q value. So you could just see the some of the field experiments which they did it. They are measuring the flow, nothing else. Here you can just see the cross section. क्या cross section आप करेंगे इसमें? Okay, it's an irregular cross section, particularly on the right side. Okay, it's an irregular cross section. It is a small stream. Okay, and they want to measure the flow. They are using sophisticated technology, of course. Okay, like your streams आप लोग भी कर सकते हैं. You can just go to the Chekperi, Beni, or your rivers, and you can measure the amount of flow which is flowing today, because now it is flowing. Okay, चेकपेरी भी फ्लो आ रहा है बारिश की वजह से. इवन आपका बेनी इसमें भी है, पानी जा रहा है. हाउ मच अमाउंट ऑफ वाटर इज फ्लोइंग, यू कैन मेजर इट. दिस इज जस्ट एन एग्जांपल ओनली. Okay, some of the equipment, some of them we have it, may not be all. Okay, that's possible, and you can use this methodology. Is just demonstrating that one, how to measure the flow. Okay, yeah, this is what I was saying. Just by measuring the height, this is a simple canal which is flowing. Okay, so by just observing that readings, okay, you will be in a position. It is an indirect method. You will be in a position to say, "Itna pani ja raha hai." That is possible, because this will be fed into your greenhouse only, or your field only. That is possible. Okay, the simple structure. This is an hydraulic structure, indirect method. It's a V notch, and yeah, this is somewhere during almost 15 years back when we visited Germany. They were showing this equipments. Particularly in the forest area, उधर तो कुछ नहीं रहता है. How to measure it? You just see. Particularly hilly area or mountainous area, it is very difficult. Okay, so there also, yes, you can just make the way such that water will flow through that. We used to call it as V notch. This one, okay, V notch, and just by measuring the depth, you will be in a position to say so much amount of water is flowing. Yeah, this is just a close-up view of that discharge measuring equipment. So I will just stop at this point. So many methods are available. I am just given overview of this flow measurements. Okay, and that too in faster way. Okay, just an introduction only. There are many details are there that may not be required because the audience is in general. Okay, so any queries, any information, please. Not necessarily on the topic. Okay, anything related with subject, or maybe in other cases also. Yes, like we discussed, I think at least we came to know that there are Panch Prayaks in Uttarakhand. Okay, because Uttarakhand is rich in water resources. Not necessarily on the paper, even you can see we have a very good biggest dams in Uttarakhand also. Okay, and different types of dams are also there. Okay, yeah, any interaction please, anything you want.
Does these weir of flumes measure a different quantity of water, or they are meant for the similar quantity of water?
No, discharge will be same, irrespective of which method. No, yeah, that accuracy may vary. Okay, suppose if I just what I understood your question is if I use current meter, in another way we are using V notch. So whether both of them giving same quantity, sorry, same discharge, yes, they should give, but based on the errors, practical errors, yes, actually it is same quantity only. It should give same quantity, but because of the different methodology which you are using, it may vary a little bit, not much, maybe less than 10% it should be, but it should give same Q, irrespective of which methodology you use it. Okay, because streams are very narrow. Like if I measure it in jQuery, okay, small amount of water is there. That also varies. Today it may be large amount of water may be there, बट वही समर में चला जाएगा कुछ पानी फ्लो ही नहीं होता है उधर. Okay, that is possible. It may be very less, maybe zero during summer, or it may be maximum during monsoon season. That is possible. That may vary. And which equipment I need to use it, that depends upon. पानी बहुत कम हो गए तो you can use simple instruments. But if the water is large, you can go in for some current, let's say current meters. And same current meter you can't use it in Ganga river. No way. सपोज बनारस में अभी पानी जा रहा है, मैं करंट मीटर यूज करूंगा क्या, आपका करंट मीटर ही गायब हो जाएगा, वो इतना पानी वेलोसिटी रहेगा. Okay, so you can use some other methodologies. You can use satellite imageries, okay, or you can use that Boeing boat method. That is possible. They are doing like that. There is a, as I said, Central Water Commission is an agency which measures the flow of entire rivers of India. Okay, you can see, you can just go to their website. You can see आज कितना पानी जा रहा है गंगा रिवर पे, आप देख सकते हैं, ऑनलाइन अवेलेबल है. Okay, you just search it, Central Water Commission. Okay, and you just take the Ganges river, Ganga river, and it asks for where. It may be at Gadmukteshwar, or it may be at Banaras, Varanasi, or it may be Farakka also. Okay, आपको कहाँ चाहिए, कितना पानी जा रहा है, you can do it. And even height also, कितना, is it flooding? Flood क्या होता है? What do you mean by flooding? Whatever that capacity of water is that has been designed, उससे ज़्यादा पानी आ गए, वही flooding है. And that is dangerous because that may occupy your residences, roads, or आपका airport भी डूब जाएगा. That is known as flooding. Flooding is nothing. It is just excess water in accordance with the capacity of the capacity से ज़्यादा आ गए तो flooding बोलेंगे, और कुछ नहीं है. हाँ.
Sir, in dilution method, do we need to know the cross section of the river?
No. It is just a concentration is required. You need to measure the concentration here at one place and at the other place. Change in the concentration will provide you the flow quantity, or you can say quantity. Yeah. No.
Sir, is there any other method in which we do not require cross section area other than
The satellite imageries. Okay, remote sensing method in other words. Like NRSC is there, you can just go to NRSC website. Indian Institute of Remote Sensing is there at Dehradun. Okay, you can just go to their website. They are monitoring some of the rivers, particularly huge, big rivers like Ganga, Yamuna, okay, or even in some of the other surface rivers. Okay, so they are measuring. You can see visually. Okay, आज कितना पानी जा रहा है, that you can get it from that one. As I said, you can go to that river gauging, any gauge. आप बनारस में आज कितना पानी जा रहा है, you can see. आज बहुत पानी जा रहा है actually last few days. Okay, so that you can see. And lean period में even history is also available, earlier records. कम पानी आज तक कितना जा रहा है वो भी आप देख सकते हैं. Nowadays, because of that sophistication, computerization, things are easier. Okay, but at some of the places, some of the parameters I was telling you, most of them are sensor based. Good sensors are available nowadays. Okay, as I was saying, there are two main radars in Uttarakhand, Kumaon region 1 and Gadwal region 1. Yeah, they are using that data only. Radars data. Radars are smaller things of your satellite imageries. Satellite में तो बहुत सारे information आ जाएगा. ये तो just for combined region only. Okay, radars. That they are sufficient. अभी तीसरा वाला भी देवस्थली. Okay, देवस्थली you know near combined region, huh? Combined region only. There only that another radar is under installation. because वो पहाड़ ज़्यादा है ना, प्लेन एरिया में तो ये रडार चल जाएगा, बट पहाड़ में थोड़ा ज़्यादा चाहिए, वही तरह से रडार इज अंडर इंस्टॉलेशन and that is costing crores of rupees. 2 in combined region, 2 in this region. And that will suffer because of the mountainous terrain. Otherwise, the UP में तो जरूरत ही नहीं है, because the south plain area, one radar can cover big area. That is possible. Yeah. Anything else? So if thing is there, I will just stop at this one. And thank you for your patience listening. At least you could learn something